So let's take a look at cosine law, specifically the missing sides case. First thing to ask is, when can we use this law? It doesn't apply as generally as sine law, so when can we use cosine law? There's a specific case when we use cosine law, and that is when we have SAS. I like to call it a sassy triangle. That's just for me to remember it. But what it really means is a side, angle, side. What does that mean? Well, let's take a look at a triangle and see what it looks like. So if you have a triangle, say this one here, it doesn't really matter. What really matters is that you have an angle that you have the value of. So let's say this one is like 45. And then you have two sides surrounding it. So these two sides make up the angle. So these are the two sides that we need the values for. So let's say it's 12 and 20. Okay, so in this case we have a side, angle, and a side. And this is the case where we would be able to use cosine law to solve for the side opposite of this angle. Okay, so let's take a look at the formula that we're going to use here. Now there's a couple different versions of this formula, but they all come down to the same pattern, and we'll go over that. Okay, so the first version of the formula that you've probably seen is this one, a squared. Now that's little a, so that's a side. So that's the side we're looking for. Equals b squared plus c squared. This might look familiar. All those squares might look a little bit like Pythagoras. We're still dealing with triangles, but there's a modification here. So we got a squared equals b squared plus c squared. So the side we're looking for, the two sides we're not looking for, the ones that we have, minus 2bc, so again that's those two sides that we have, then cosine of big A, so big A, so that's an angle. Okay, so a squared equals b squared plus c squared, minus, that'll be important, 2bc cos A, and remember that means that's all multiplied together. Okay. If we were looking for a different side, if say b was the side that was missing, we'd just use b on this side instead. B squared equals, and then wherever we had b, we just write a instead. So we'd write a squared plus c squared. So again, if our sides are a, b, and c, we have the side we're looking for here, the other two sides on this side. Okay, then minus 2ac cos, and then big B, because it's the pair for little b. Okay, and just to finish out the set, if we had c squared, it would be a squared plus b squared minus 2ab cos c. Okay, again, when I do these, I only actually remember one of them. Just remembering that rule of the unknown on this side, the other two sides on this side, means you can derive any of these formulas as long as you know just one of them. Okay? But those equations aside, we need to know how to use it. Okay, so let's go quickly over the steps to using cosine law, and then we'll do an example. Okay, so the steps I like to take, and I'll just kind of go over these quickly because we're going to do them in practice in just a moment. The steps I like to take are, first, label the triangle. Okay, this is the first step in every trigonometry question forever. So label the triangle. That's the sides and the angles. Choose a formula. Oops. Okay, so that's from the selection above. Once you've got the formula, you plug in your numbers. Okay, because you should have basically every variable on this side of the equation you should have for cosine law to work. For calculate the solution, we'll go into greater detail in the example. And once you have a solution, you'll notice that all of these equations solve for the variable squared. So once you've solved for the variable squared, we just have to undo the square by taking the square root. Okay, I like to keep these two steps separate just because it's nice to have that final step that we always know, just so it's once we've gotten here, we know that we can finish it. Okay, so let's take a look at an example here. So this triangle here, we've got a side of 22, an angle of 69 degrees, and a side of 23. Okay, we see that we've got a side and a side surrounding an angle, which means we can use cosine law. I mean, we knew it was a cosine law question because I brought it forward, but if we didn't, that's how we'd know. So this question we're going to be finding side AB. So as a reminder, side AB is just the side that goes from point A to point B. Let me draw that line in there. I like to draw this line just because it helps me remember what I'm looking at, so I don't have to keep yet another thing just floating in my head. Okay, so let's start with step 1 here, which is labeling our triangle. Okay, so big A is across from 23, so that makes this little a. Big B is across from 22, so that makes it little b. And the big C is across from little c. Okay, simple as pie, but we need to do it in every question to make sure that this equation works. Speaking of equations, we look and we see that AB is side little c, which means the equation that we choose, which was our second step, is going to have c, little c, on the left-hand side. So looking back at our examples, we can see that the equation we're going to use is little c squared equals a squared plus b squared minus 2ab cos big C. Okay, so that's our formula. Now we plug in our numbers. Okay, so c squared, we leave it alone. We don't know what little c is, that's the whole point. So we leave it alone. Equals little a squared. Now little a is 23. We can see from the triangle there. Remember, we keep this as squared. It is 23 squared because it was a squared. Then we add b, which was 22. So we have 22, again squared, minus 2. We've got a, which is again 23. B, which is again 22. And then cos, remember we keep the cosine here. And then C is 69 degrees. Okay, now this is a whole lot to deal with, or it looks like a whole lot to deal with. But this is one of those questions where if we just take it step by step, pass by pass, and just solve what we can on each step, it'll solve itself in no time. Okay, so let's take a look here. So we've got c squared, again, leaving it alone. Okay, then on this pass we can start solving just the squares. So 23 squared, or 23 times 23, is 529. You can check that on a calculator if you like. I know I use one when I do this. I don't do this in my head. Okay, plus 484, which is 22 squared, minus, now I like to keep all of these together, and then keep this on the side. I'll show you why in just a moment. Okay, so let's multiply these together, since if they're in brackets, that means multiply. So 2 times 23 times 22. Okay, so 2 times 23 times 22 equals 1012. Whoops, 1012. Okay, and remember that minus is kept there. We haven't done anything with that yet. 1012, and that still times the cosine of 69. Okay, so if we find the cosine of 69, we will find a great big decimal number. If you find a number that's above 1, or if you find a number that you don't know if it makes sense, make sure that your calculator is in degree mode. Okay, so we'll just keep 4 decimal places here. It gives us 0.3584, just rounding up that last one. Okay, now it didn't happen in this question, but just to let you know a little trick here, cosine can be negative. Okay, and if cosine is negative, we have to make sure that we're careful about this next step when we start multiplying these two values together. Okay, because we have to remember that this 1012 is negative. So if we have a negative 1012 times a negative cosine, then we'll end up with a positive number. Okay, in this case we have a negative 1012 and a positive cosine, so we'll end up with a negative number. Okay, it's a very easy way to mess up the question, very simple mistake, just one notation, and suddenly you have the wrong answer, but it will look right. And that's the problem, is that it will look right. So we have to make sure that we're being careful about those signs so that we don't end up with an answer that we don't even know why it's wrong. Okay, but if you do get a wrong answer, it's a good place to check. So let's finish out this question here. So we have 529 and 484 that are adding together, so we can certainly just add those together here. So if we take 529 and add it together with 484, we end up with 1013. Then we do minus, since we know this is going to be a negative number, and we had 1012 times 0.3584. Okay, and that'll give us, again, I'll round this a little bit, 362.7. Again, I've just rounded that. Okay, so now we're down to a fairly simple equation here, which we can certainly do. C squared equals, and that's 1013 minus 362.7, which will give us 650.3. Okay, so that is all of our solving there. That's our calculating the solution. Our last step is to get rid of this square, because you know what? We have c squared. We don't care about c squared, though. We care about c. So to get rid of this square, we have to do its opposite. That's how we get rid of things in math. We do the opposite. And the opposite of a square is a square root. Right, so that'll get rid of the square, but math is fair. So we have to do the same thing to the other side, no matter what we have. Okay, so if we take the square root of this answer here, so square root of 650.3, we will end up with, I'm just going to rewrite the c here, c equals 25.5. Okay, and that is our final answer there. So from going from knowing just a side and an angle and a side, we now have our unknown side.